Analyzing functions, algebra 2, trigonometry regions. What is the domain of the given relation? There's a lot of vocabulary in this video. The first is a relation is just a set of ordered pairs. And it could be anything. It could be height, comma, weight, but typically what we're going to use it for is coordinates, x, comma, y. And then relations could also be functions, but we'll talk about that a little bit later. But in a relation, there are two things. There is a domain, which this question is talking about, and then there's also something called the range. See, a function needs to be thought of, like let me give you a little example before we even get to this example. If I had a function, like say we had this equation, y equals x plus 2. A very simple, very basic equation. It can be written in what we call function notation as, instead of y equals, f parentheses x. But the way we say it is we say f of x. So f of x equals x plus 2. And basically f of x is the same thing as y. And this is called a function, and there is going to be an x and a y value, generated from it. But we think of the x values, we call them input values. And we think of the y values as output values, because what's going to happen is I plug in x values and I get out y values. For like the y equals x plus 2 or the f of x equals x plus 2. When I plug in a 5 here, 5 plus 2 is 7. So if I plug in a 5 into this function, if I plug in a 5 for x, I get out a 7. And so this f of x notation would just be written as f of 5 is how I would be writing that. I want to put an input of 5. And when I put an input of 5, I replace my x with 5. I get 5 plus 2, and I get an output of 7. And so this concept of input-output, you'll hear us discuss a lot throughout this chapter. It's a big part of what functions are. But the collection of input values, all the x values, we also refer to as the domain. And the collection of y values we refer to as the range. So x is domain, and y is range. So the set of x values that you put into your function is your domain, and the output that you get from those is your range. And so this question is very simple. When they say what is the domain, they just mean what's the collection of x values. We have -1, 4, 4, and 1. And we're not going to list 4 twice, so it's -1, 4, and 1. -1, 4, and +1. The answer here is D. Now, when we get into determining if it's a function or not, this would not be a function because you can't have any input values repeating for separate output values, but I'll get into that another time. For now, just remember domain x. So this next question is simply asking you what is the domain and what is the range of this function. And so we'll treat them separately, but the domain, and I'm going to use this notation d of x, d subscript x. So d and then a little x. And that's how I'm going to be expressing domain. There's a lot of ways that you could express domain. So the domain, if we take a look at this graph over here, excuse me. Sorry, my computer's having some technical problems. See that my cursor is kind of jumping all over the screen. I'm going to try to fix this for a second. Hold on one second. All right, so trying to fix my computer from. All right, anyways. So the domain, the x value. Taking a look at this graph, we just want to, evaluate the x-axis because that's our x values, and we see that this graph goes as far left over here, and this would be -5, and then it goes all the way to the right over here, and that would be a value of +8. And so my domain would be written as this: -5 less than or equal to x less than or equal to 8. Because, see, the graph is in between -5 and 8, so all these x values are in between -5 and 8. Like this point would be -4, -2. This would be 0, 2. This would be 4, 0, 5, -1, and so on. So, but all x values have y values between -5 and 8. And then our range is simply our domain x, range is y. And so in my range, I'm going to use r with a little y, and that's, you know, my y-axis. How low and high does it go? So I go as low as -3, and I go as high as +2. So it has nothing to do with necessarily as the endpoints here. It's just the graph as a whole. How low does it go? How high does it go? Domain is how far left, how far right. You know, what is the domain of the x-axis? You know, how many x values have y value coordinates? And then the range is the same thing, but for the y-axis. And so the range would be -3 less than or equal to y less than or equal to 2. Okay, state the domain and range of the function y equals -3x minus 2. Now, for this question, and for questions like this, what you're really going to want to do here is, it's helpful to type it into your calculator. I don't have my calculator up right now, but what is this? Y equals -3x minus 2. Y equals -3x minus 2 is simply just a line. And it's going to be crossing the y-axis at -2, and it's going to have a slope of -3. And so it'll be something like, something like that. But we know that lines have arrows on the ends because they go on forever. So your domain here, your x-axis, how far left is this going to go? Well, as it continues up, it's going to continue left. So it goes all the way left to -infinity over here. And as it goes down, it goes right. So it's going to go to +infinity here. And so your domain has no restriction, what we call it. There's no x values that this line, there's not any x values you can't plug in here and get out a y value, right? I could plug in a 5 and I'll get some number for y. I could plug in a 17. I could plug in a million. I could plug in -2 million. You're going to get a y value. There's no restriction to this domain. And that's what this symbol is right here, this weird looking capital R. It stands for the word or the sentence, all real numbers. And it's basically saying x is everything. All real numbers, -infinity to +infinity. Any number can be plugged in for x. And then you actually get the same thing for y here. It goes all the way up and it goes all the way down. There's no restriction. So it goes all the way up to infinity and all the way down to -infinity. And so y is all real numbers as well. And so for this question, I really just wanted to kind of point out what this symbol means. It just basically means there's no restriction. Because a lot of times there is a restriction. Like if we look at this next one, notice that it's a square root. Now this symbol is real, so when we talk about the domain and range, we're talking about real numbers. And we know that there is a restriction for radicals. Sometimes we end up with imaginary numbers, and they can't be in the domain. So whenever you have a radical, it must be positive. You know, we can't have negative. Can't be negative. Because if it's negative, that's going to be imaginary. And that's not going to work for us. And so the procedure here, now you can type this into your calculator, take a look at the picture, and that's helpful at times, but the procedure is going to be, this can be 0. It can be positive. It just can't be negative. So what you can do is you could take your x minus 2 and set it equal to 0 and solve that. If we solve it, we get x equals 2. And so 2 is going to make it 0. Well, what would make it negative? Numbers greater than 2 or less than 2? Well, let's see. If you plugged in a 1 in here, you're going to end up with negative. So numbers less than 2 produce negative. That means x has to be greater than or equal to 2. X must be greater than or equal to 2. So remember what we're trying to do. We're trying to create a list of all the values x can be. So these are the numbers x can be. I don't know why I write can be there. So these are the numbers that x can be. X can be. X can be 2. It can be 3. It can be 4. It can be 5. It can be 6. It can be 7. It can be all those numbers. They will produce real solutions. They may be irrational. Like if you plug in a 3 here, you get, well, that's not going to work. If you plug in a 7, 7 minus 2 is 5, and square root of 5. It's irrational, but it is a real number. It's just a repeating decimal. Well, not repeating decimal, but it's just a never-ending decimal. So these are the things that x can be, and so that's our answer. And your range you get from those. Talk more about that another time. Just want to get to one more option here. So when you have a square root, you have to say all the things x can be, and you're basically restricting it to the numbers that x can't be, because that would produce imaginary numbers. When it comes to fractions, we don't mind negatives. The one issue is that we can't have an undefined situation. You can't end up with 3 over 0. The bottom can't be 0. And so what you do with these fractions, you end up basically saying that x can be all real numbers except for the few numbers that will make this 0. So you can't divide by 0. So what would make this 0? Again, you could set it equal to 0 and solve. I think you could probably do this in your head, but you simply see that if x equals 2, this is 0. So that means that x can be any number except 2. And that's really the two important things for, domain x, range y, you need to know that, of course. But when it comes to square roots, figure out what would make it, 0, and then x has to be, a restriction from there. X can be the numbers that will make it positive. It can't be what will make it negative. And when it comes to fractions, you basically just take a look at your denominator and say x can be everything except what's going to make that 0. Sorry the video ran a little bit late today.